Okay, welcome to Chapter 5. We are going to be getting into some geometry. So geometry, we are going to start by this section title here is classifying angles. So this is all about different types of angles. And yes, this is pre-algebra, but the authors of your textbook wanted to expose you to a little bit of geometry because a lot of you, all of you, are going to eventually have to be in some kind of geometry course. So we're taking a little break from pre-algebra, but we are going to tie in a lot of the different concepts that we've used so far in this chapter. So right away, the section is classifying angles, so let's talk about some angles. So what types of angles are there? So an acute angle, let me type this out here today, go a little bit faster. An acute angle is an angle whose measure is less than 90 degrees. And throw in the degree symbol here. Beautiful. All right, so an angle whose measure is less than 90 degrees is an acute angle. So that would be a little guy, a little cute angle, okay? Less than 90 degrees. So a 90-degree angle, actually that's the next slide right here, it's a right angle. A right angle is an angle whose measure is 90 degrees. And just to show you what I'm talking about when I talk about angles, so an angle is the space between two intersecting lines, or you could say between two rays. It looks just like this. And I'm just going to pull up a protractor. All right, so if we're talking about angle measures, if you start with one ray here, and then you work your way around and make another ray there, you can see the 90-degree marking. So if you have one ray vertical and one ray horizontal, that would be a 90-degree angle. In a circle, so 90 degrees is a quarter of a circle, 180 degrees is half of a circle, and then if you go all the way around a circle, that'd be 360, which means 3/4 of a circle is 270 degrees. 270. All right, so a right angle is a 90-degree angle, so that is going to be like the corner of a piece of paper. And this little symbol that I just put here implies that it is 90 degrees. It's just like a little box. That symbol means it's 90 degrees. Here it's not a box, it's a curve, and that just indicates that it's some angle. All right, an obtuse angle is an angle whose measure is not 90, not less than 90, so greater than 90, greater than 90 degrees. Obtuse angle, an angle whose measure is greater than 90 degrees. So if you have 100 degrees or 130 degrees, anything greater than 90 is an obtuse angle. And I should say that it's also less than 180, because if it's exactly 180 degrees, then we get to the next one. So a straight angle is an angle whose measure is 180 degrees. So a straight angle, it's called a straight angle because it looks like a straight line. So we have one ray extending out here, and then the other ray going all the way around 180 degrees, extending exactly in the opposite direction. So if I show you that protractor, the protractor again real quick here, 180 degrees, you start here at 0, you go all the way around, and you can see the 180 right there. So one of these is going out to, starting at 0, and then going all the way around to 180 degrees. It makes a line. On the next slide here, we are talking about some angle pairs. So I should actually indicate that here. So different angle pairs. So some angle pairs, complementary angles. So again, we've got a lot of vocab going on here. Complementary angles, excuse my text box here. Complementary angles are two angles whose sum is 90 degrees. 90 degrees. All right, so what do I mean? There's some math words in that sentence right there. Two angles whose sum is 90 degrees. Hopefully you are starting to catch on to your math vocab words. Sum implies addition. So if you have two angles and you add them together, and when you add them together you get 90 degrees, then they are complementary. To be supplementary angles are two angles whose sum is 180 degrees. So if you add them together, you get 180 degrees. So one way that my high school math teacher, way back in the day, taught me about complementary and supplementary angles, it stuck with me ever since they told me this. So I want to share it with you. They said to help you remember complementary versus supplementary, you just look at the first couple or first few letters. I have a C and an O. Well, CO, I can make that into a 90 degrees. Well, two angles whose sum is 90 degrees. So just to really make my point, I'll put this in red, 90 degrees. That's from the C and the O. Supplementary, I can make the S into an 8, and that's a bit of a stretch, but I can make the U into a 0, and then I can just throw a 1 out front, so 180 degrees. A little bit more of a stretch here for 180 degrees, but like I said, it stuck with me all this time, so I figured I might as well share it with you. It might help you also remember complementary versus supplementary angles. Complementary angles, their sum is 90 degrees. Supplementary angles, their sum is 180 degrees. All right, so on the next one, again, it says angles, so we have more angle pairs. So I'll just copy this over here, some more angle pairs. So congruent angles. Congruent angles are two angles that have the same measure. Two angles with the same measure. So if you have one that is, let's get a different color here. If you have one that is, let's go with 50 degrees, then to have a complementary, oh, excuse me, I said complementary. I was thinking of my last slide here. In order to have a congruent angle, I would have to have another angle that is 50 degrees. And it doesn't have to be in the same orientation. I mean, I could even flip it back this way. Doesn't matter how far the rays extend. If it's also 50 degrees, that distance between those rays, then it is also it's called a congruent angle. And I said distance, I should say rotational distance between those two rays. All right, next up we've got vertical angles. So vertical angles, if I were to draw two lines, and I know you've seen these before in pre-algebra, so this should look familiar. Vertical angles are two angles that are directly across from one another. So that's one example of vertical angles in this diagram. I could also make another one. So these are vertical, but also the angles cross from each other the other way. So this angle right here and this angle right there, those are also vertical angles. So two angles directly across from one another when you have intersecting lines. So let me just sum that up and type out the definition. So vertical angles are two angles formed by the intersection of two lines, two angles across from one another, formed by the intersection of two lines. And the other piece of vertical angles is that vertical angles are congruent. So let me add that to your notes here. Vertical angles are congruent. And again, congruent means that they have the same measure. So this angle is the same as that angle, the same measure. This angle is the same measure as this angle. All right, so we've got a lot of different angle types of angles: acute, right, obtuse, and straight. We've got different angle pairs: complementary, supplementary, congruent, and vertical. So we've got a lot of vocab already. We have 4, 5, 6, 7, 8 different vocab terms at this point. So let's try to apply some of them here. So it says, tell whether the statement is always, sometimes, or never true, and explain. I like these kind of questions. They're kind of like mind puzzles. You got to think about them a little bit. So it says if we've got two angles, x and y, and they are supplementary, then x is obtuse. So we've got some different vocab right there. So what is supplementary? Well, if I go back into my notes here, looking for supplementary angles, remember my little trick to remember that that's two angles whose sum is 180 degrees. So it says if x and y are supplementary. So in other words, if I add them, I get out 180 degrees. Then x is obtuse. So what is an obtuse angle? So again, go back to my notes. Obtuse angles are angles whose measure is greater than 90 degrees. So then x is obtuse. X is greater than 90 degrees. So is this statement always, sometimes, or never true? That's what it's asking me to think about. So let's see. If x and y add to 180, does x have to be greater than 90 degrees? Well, let's think of some different possibilities. So I'll say case number one. Case number one. Let's say Let's try to make this true if I pick a number greater than 90. Let's say if I let x equal 100 degrees. So that's an obtuse angle. So x is obtuse. So if I say x is 100 degrees, I don't know what y is yet. So what would y have to be to have 100 plus some value to get out 180? And you can definitely tell it's 80, just 80. So you could subtract 100 from both sides. If I subtract 100 from both sides, I would get 80 on the right side. So y equals 80. So is that statement always, sometimes, or never true? Well, at this point, x and y are supplementary. Okay, yep, they add up to 180. Is x obtuse? Well, yeah, it's possible. I said if x is 100, we have another angle here that would have to be 80 degrees, and then, yeah, they'd add to 180. Well, x is obtuse. So case number one, x is obtuse. Okay, let's try to find another example where x is not obtuse. So where x is not obtuse, so I'll call this one case number 2. So in this case, let's say x is not obtuse. Let's pick a number that is an angle measure that's less than 90. How about if x is 80 degrees? Let x equal 80 degrees. If that's the case, well, 80 plus y still has to equal 180 because it says that x and y are supplementary. We're stuck with that. They can't be anything other than supplementary because it says they are supplementary. So subtract off the 80, and you get that y is 100. Well, yeah, that's still possible. You could have an angle that's 100 degrees where x is 80 degrees, and they are supplementary. So is x obtuse in this example? No. So x doesn't have to be obtuse. It can be obtuse, but it doesn't have to be obtuse. So is it always true? Nope, because we just saw in case number 2 that it could be acute. Is it never true? Well, no, because we saw in case number 1 that it could be obtuse. So it must be sometimes true. So I'm going to say x, I'm going to say tell whether the statement is always, sometimes, or never true. I will say the statement, let me type this one out. The statement is sometimes true. In case number 1, x is obtuse. But in case number 2, x is not obtuse. And I could have said x is acute, which implies that it's not obtuse. But the statement is sometimes true in case number 1, x is obtuse, but in case number 2, x is not obtuse. So that is why it is sometimes true. All right, let's try one more of these. So this says, tell whether the statement is always, sometimes, or never true if x and y are right angles. So they are right angles. Again, if we go back in our notes, a right angle is an angle whose measure is 90 degrees. So if both x and y are right angles, right here this tells me that x and y are each 90 degrees. That's their angle measure. And x and y are supplementary. So supplementary right here, again, from the last example and from the notes, it means that if we add them, we get out 180 degrees if we add their angle measures. So if they are right angles, if x is 90 and y is 90, does that automatically make them equal 180? Well, if we take x plus y, what do we end up with? Well, if x and y are stuck at 90 degrees each, so x is 90 and y is 90, that equals 180. So in this one, there's no other option for x or for y because it says they are right angles, which means they are 90 degrees. So in this one, I'm going to say the statement is always true. Since x and y are each 90 degrees, and 90 plus 90 equals 180, x and y are always supplementary. So again, the statement is always true since x and y are each 90 degrees and 90 plus 90 equals 180, as we saw right here. X and Y are always supplementary. So again, you're just trying to think of different possible cases, but in this one, there's no other possible case because it says that X and Y are right angles. You can't change that fact. They are right angles, which means they are 90 degrees each, and that will always add to 180, which makes them supplementary. All right, let's take a break from those intense thinking problems. Let's go to something a little easier. On this one, it says find the value of X and explain how you know. Hopefully you're looking at this and you're thinking back to this slide with vertical angles where it says vertical angles are congruent, and congruence means they have the same measure. So if they have the same measure, they're right across from each other, so they're vertical. Well, that means that X is 100. There's no other possibility because they are vertical angles. So I'm going to just, it says explain how you know. I'm going to just type that out right here. So I'm going to say that X equals 100 since it is a vertical angle with 100 degrees. And then again, vertical angles are congruent. I might as well make that into one sentence. Throw in a little comma. All right. Oh, that's a real little comma. Let's take that out of the exponent. And vertical angles are congruent. So that was a lot easier than the last two. You're going to see a lot of problems like this on your assignment. So let's go on to the next one. On this one, look at this. We've got an angle here and another angle there. What do those two angles make if you get rid of this shared ray? Well, they make a straight line. I shouldn't say straight line. All lines are straight. So if they make a line, what do they have to add up to? So I explained this before when I was talking about this protractor. If they make a line from 0 all the way up to 180, they have 180 degrees between them. So they add to 180 degrees. So what kind of angles do we have if they add to 180 degrees? Hopefully you're thinking supplementary. So we have some supplementary angles. So they add to 180, which means I can create a little equation. X plus 114 must equal 180. We can solve this equation by subtracting off 114 from both sides of the equation, and you get X equals, oh, let's see, 66. So X is 66, and it says explain how you know. I'm going to type this one out again. I'm going to say X equals 66 since it forms a straight angle pair with 114 degrees. And straight angle pairs are supplementary because they form a straight line and there's 180 degrees in that straight line. So maybe I should add that to our definition that straight angle pairs are supplementary. So I'm going to go back to my notes here. Straight angle. So that's not for an angle pair. That's why I didn't put this earlier. So this is just a single straight angle. But if I have a straight angle pair, I'm going to consider this part of my vocabulary now. Straight angle pairs are supplementary. If they form a straight line, there's 180 degrees formed if you have a straight angle. So that means that those two angles must be supplementary. So my apologies for not putting that in there sooner. All right, let's go into the next one. Right here, we've got that little box symbol. So if you're thinking back, hopefully you're thinking about this one. The right angle, an angle whose measure is 90 degrees, we have that little box symbol to imply that it is a 90-degree angle right there, a right angle. All right, so on our current example, we've got a right angle, which means they add to 90 degrees. So X plus 64, when we add this guy with this guy, they equal 90. Now, how do we solve that? Well, we undo the addition using subtraction. We subtract 64 from both sides of our equation, and we get X equals 26. So write an equation to find the value of X, done. Find the value of X, done. All right, let me write, oh, this one does not say explain. I would have said that they are adding to 90 degrees. What do you call two angles that add to 90 degrees? I don't know how many of you are sitting there like shouting these answers out. Maybe nobody. That's okay. But they are, let's look back at this one, complementary if they add to 90 degrees. All right, so that is my explanation, but it does not say you have to explain on this one. So let's do just a few more. I've got 4 more examples. They're going to go by pretty darn quick though. So on this one, it says tell whether the angles are complementary. Remember that little trick? They add to 90 degrees. Supplementary, they add to 180 degrees, or neither. So let's see, what do we have here? 52 and 128. Well, visually, it looks like they make a line, but maybe it's off by just a little bit. So let's just double check. Do these add up to 180? Do they add up to 90? Well, obviously they can't add to 90 because this angle is already more than 90. So let's see, do they add up to 180? So 128 plus 52, if you have to bust out the calculator, that is okay, but 128 plus 52 is 180. I'll just show that work here. 128, I don't like writing in red. Let's get rid of this. Let's go with, I'll mix it up a little bit. 128 plus 52 is 180. So again, that tells me that they are supplementary. I'm just going to circle that as my answer. They are supplementary because they add up to 180 degrees. On the next one here, same directions, complementary add to 90, supplementary angles add to 180 degrees, or neither. So let's see, 140 plus 30, what do you get when you add those two together? Well, it is only 170 degrees. So this one, I'm going to have to say neither, because they don't add to 90, so they're not complementary. They don't add to 180, so they're not supplementary. So it's neither. This one here, same directions. 2 angles that are complementary add to 90 degrees. 2 angles that are supplementary add to 180 degrees. And if it's neither, then they don't add to either of those. So 57 plus 33 is 90. So what kind of angles are these? Complementary. So I'm just going to circle that one. And then finally, the last example is a little bit different than what we've been talking about so far. It says name the angles in the diagram. Name the angles. Well, in this one, we've got a lot of different angles in this one diagram. So let's see. I'm going to start with this angle right here. And then we need to talk about how do we go about naming that angle. So when you name angles, we start by putting the angle symbol to indicate that it's an angle. And then we always go in alphabetical order. So A, B, F, angle A, B, F. And the reason we go in alphabetical order is just because it's much easier to see. If I were to write FBA and say, oh, I've got 2 different angles there, it's much easier to tell that, oh, really, that's one and the same. So you don't want to have to write it more than once. You don't want to accidentally write it more than once. So we just go in alphabetical order to help us realize that we already have that angle taken care of. All right, so what other angles do we have in this? So let's go with angle A, B, D. There's another angle. It's angle A, B, D. And we'll just keep on going, trying to find all the possible angles. If I miss one and you find one that I don't put down and you send me, let's go with a message on Schoology and you are right, I'll add an extra credit point to your homework. So let's see, I'm going to try to find all these in here. So I'm starting with A, let's just keep going with A. So I also have angle A, B, C, a straight angle pair, angle A, B, C. All right, so that was starting with A. Let me go and try to find some other ones here. What if I start with, let's go with starting with C. So if I go C, then I have B and then D. There's another angle. So I said you have to go in alphabetical order. Well, how do you go in alphabetical order? Do I go B, C, D? But no, that wouldn't work because that would actually be this angle right here, B, C, D, and I don't have that angle on my diagram. So when I said alphabetical order, what I meant is go in alphabetical order with the 2 points that are not what's called the vertex. The vertex is where the 2 rays converge. So this is called the vertex. So go in alphabetical order with, in this one, A and F, A and D, A and C. And on this one, I'm going to say C, B is the vertex. I'll put that right in the middle, and then D. So C and D are the 2 that I need to, the 2 letters that I need to have in alphabetical order. All right, so C, B, D is another one. And then let's go with, I'm running out of colors here. Let's go try to find another one. Yellow's going to be hard to see. All right, so let's see. I also have this angle right here. What angle is that? Well, which comes first in the alphabet, F or D? So D comes first in the alphabet, so I have to say angle D, and then go to the vertex B, and then the other ray F, CBF, is another angle. And let's see, maybe I should miss one on purpose just so you guys can get some extra credit. I'm going to keep trying to find them. All right, so let's see. I also have this angle. Did I already mention this one? Yes, I did. ABF. I've got that one already. I've got the straight angle. Oh, I see. I've got a couple more. ABD. Oh, I got that one already. But what about if I go this way? CBF. CBF. Angle CBF. So let me just see. I've got 1, 2, 3, 6 angles. Is there anything else on here? I've got ABD. Yep. You know what? I think I got them all. I'm not going to spend any more time looking at this because maybe I missed one and that's okay. I don't mind if you guys get some extra credit. But that is how you name the angles in the diagram. Just make sure you go in alphabetical order with the first and the last letters. Other than that, I think we are good to go. I think we're ready for that assignment. So this is your assignment, page 188. It used to have 2 pages. I cut this in half for your online schooling. So hopefully this is enough. If we need more practice, I'll take a look at your homework and see how we're doing. If we need more practice, we can always spend another day on this material. Don't forget, you turn your homework assignments in on Schoology. So one more reminder of that. Keep turning them in on Schoology. Don't send me emails with your homework. Otherwise, I get way too bogged down with emails. So, all right. Thank you very much.